If we are discussing energy, energy is defined as the capacity to do work, as it says. SI unit of energy is joules, and the important thing is energy is only a scalar concept. For example, if you say heat energy, it is of 10 joules, or if you say sound energy, light energy of let's say 100 joules, then that doesn't mean it is having any direction. It basically means that it is only a value. So it is a scalar concept since it doesn't incorporate any direction. If we are discussing forms of energy, so energy can be of various forms, starting from potential to kinetic. There are basically two different forms of mechanical energies. Then we may discuss electrical, heat, light, or nuclear energies. Starting with the kinetic energies, what we can see is energy required or energy that can be converted by the virtue of motion is known as kinetic energy. As you see this in this windmill, if it rotates, what happens? This is basically kinetic energy, that is energy associated with moving object, and that kinetic rotation can be converted into electrical output as a source of work. Same goes for here, as these basically people are ramming this door, so they are utilizing their kinetic energies to break this door up. Energy that is stored in any system is potential energy. Let's say if you're talking about cells, these cells they have some chemical potential energy stored in them, and as you plug in them, they basically release some electrons and charges that carries that completes the circuit and the circuit works. Same goes for this elastic spring. This carries elastic potential energy that can be utilized in shooting of arrows or targeting any object. Same goes for the crane. If it lifts something up from this point to this point, then that basically is increasing the or storing the gravitational potential energy. What is principle of conservation energy states that it says energy can neither be created, it cannot be destroyed, but it can be converted. How can we understand that? You can see this as an example. If we are talking about a cyclist that is basically having kinetic energy, and let's say if we say that these this cyclists have a kinetic energy of 20 joules, and as it runs there is a dynamo attached to the tire, and this dynamo runs, and as a result this 20 joules of kinetic energy is converted into electrical energy that may be utilized as light, heat, and sound. But the idea that incorporates here is there is no loss of energy, and we are converting from one form to the other form. Then that means kinetic energy is not destroyed; it is only converted to electrical. Another possible application can be of law of conservation of energy. We are considering a motion of pendulum as it moves in between W and Z. The potential energy or gravitational potential energy at W gets converted to kinetic energy at Y, and then that kinetic energy gets converted to potential energy at Z. So that means whatever your potential energy is here, it converts into kinetic, then to potential, then potential gets converted to kinetic, and then back to potential. The idea is of wide importance if you are considering no loss of energy. Okay. If you are considering a non-ideal pendulum, a pendulum that utilizes some losses, so that means if let's say there were 10 joules of potential energy here, there would be 10 joules of kinetic energy here. Of kinetic energy is here, and that 1 joule might be lost to air resistance or some sort of friction, and then still if you are having 9 joules as kinetic energy, it won't be available as 9 joules of potential energy. It might be 8 joules of potential energy and 1 joule to energy losses. So if you are having a non-ideal pendulum, it is always associated with some kind of energy losses. How would you calculate efficiency? Efficiency is always calculated as a ratio between output and input. So whatever energy is supplied to any object gets converted to useful output delivered by that object, and energy wasted through the process. Formula can be utilized as expressed as energy output over energy input times 100. Since the efficiency is expressed in percentage, so we multiply it lastly by 100%. Now, what is work? Work is basically the product of force and displacement. Let's say if we are having an object at A and there is some kind of force that acts on object A and it moves in the direction towards the B. So what we can say is since force and displacement are happening to be in the same direction, there is some work done on the object, and work is expressed in joules. As it basically is a mathematical form of energy. So energy also along with the work has the same energy units as joules. Let's consider this. If you are considering the motion of this boy who is moving in this direction, then that means displacement is in this direction and force is directed upwards. So we can easily predict that there is no work done here. Why is that so? Because force is having a different direction as compared to displacement. Had they been in same direction, then only work would be there. There are some work examples related to work. It says a boy pushes a box across a rough horizontal surface. This is a force acting 5 Newton and it is a displacement in the direction of basically force. So we can calculate work using the formula that is force times displacement. Answer would be 10 joules. Work can be stored as kinetic energy whenever we work on an object and it starts to move. Then we can say kinetic energy is basically gained by that object. M is the mass of the object in kilograms and V is the speed of meters per second. So working with the work example, let's say it says a 50 grams toy car, this is mass, is moving with the speed of 2 meters per second. So the only thing that needs to be converted here is mass from 50 grams to kilograms. That means dividing it by 1000 will get 0.05 kilograms. Then this means 0.1 joules. Gravitational potential energy is another form of energy. So if we are working on the object such that it moves against gravity, then that means we are restoring basically or increasing the gravitational potential energy of that object. So calculating work in here, force basically would be weight, and that weight can be calculated by using the formula weight equals mg. So mg times h is basically gravitational potential energy of the object. Question related to gravitational potential energy. It says 5 kilogram box is raised to 50 meters. Height is given with a gravitational field strength of 10. So according to the formula, gravitational potential energy is given by mgh. Mass is there, g is there, and h is there. Multiplying them, we get gravitational potential energy or work needed to raise this object to this much height. Another example, let's say the ball of 500 grams, 500 grams needs to be converted into kilograms. So 0.5 kilograms is dropped from a height of 10 meters. Height is there. What is its gravitational potential energy? So we can calculate using the formula mgh. Then it says determine its velocity. So let's say if this was a ball that was at height 10 meters and it is basically falling down. So just before striking the ground, what we can assume is this 50 joules potential energy is converted to kinetic energy in its entirely, and we believe that there are no losses of energy. So what I can say kinetic energy would be 50 joules, and that 50 joules can be accordingly utilized to convert to speed that is 14.1 meters per second. A 500 gram ball is thrown vertically downward from a height of 10 meters. Again there. Height is there with a velocity of 5 meters. It hits the ground and bounces. It then rises to a height of 8 meters. They determine the energy loss. So how can I calculate? So total energy is kinetic plus potential and final energy is kinetic plus potential and energy lost due to power. So kinetic energy is half mv square, potential energy is mgh. Final kinetic energy is 0 since it would be bouncing. So there it would be apparently in rest for a certain time. Potential energy due to some compression in that ball and energy loss. So substituting these values, energy can be calculated to 16.3. Coming towards the last topic, it is power. Power is defined as work done per unit time and it is measured in watts, where 1 watt is equals to 1 joule per second. How we calculate power? It says 60,000 joules, so this is work in 10 minutes. Time should be converted into seconds, so it's times 10 times 60. Answer is 100 watt. In another example, let's say the kettle is rated at 1850 watts. So power is basically given, determine the maximum amount of thermal energy or work are required generated in 1 hour. So time would be in 1 hour 3600 seconds. 3600 seconds. So how can I calculate energy? This would be the formula that is power times energy and we get this answer. An electric motor in a washing machine is rated at 1.0 kilowatt. That means 1000 watts. Since it says kilowatt, efficiency is 40%. Find the amount of useful energy produced half an hour. In half an hour, that means I can use the conversion factor from hour to minutes. So power times time, since half an hour means 30 minutes and 60 seconds. So I'm getting my work as 1.8. So efficiency is output over input. So it says 40%. And then I calculate the energy output accordingly.